This is Unit 3, Lesson 6. We're going to do the relationship between GPA and ACT, where we're going to actually look at the least squared regression line and talk about why is it called the least squares regression line. All right, so the first thing that we did is we grabbed this data, which I'm going to remind you again how to graph it. So you're going to put it in your graphing calculator. So menu, list and spreadsheet, and I'm going to put this here for my X is going to be GPA. And the GPA values were 3, 3.5, 3.1, 4, 3.7, and 3.1. And then ACT was 19, 27, 22, 31, 26, 19. Okay, so then I'm going to go ahead and graph it. So menu, data statistics, and that's going to be GPA. So I'm going to go down to GPA. And then ACT. And then I'm going to make my line, which is menu, analyze, regression. And number 2, show linear. Okay, so that's all I'm going to do for now, and then I'm going to do one more thing. I'll jump back over in a second. But now what it's doing is it's showing your squares on here. So it's showing the least squares regression line, and we're going to talk about why it's called least squares regression line. So I'm going to go to menu, analyze, and you'll see regression, and I have show linear. Oh, you know what? On mine, interesting. Okay, so on this particular calculator on here, it doesn't show what I was about to show, so I'm just going to have to talk you through it. So you're going to go menu, analyze, regression, and then you will see residual. You'll have menu, analyze, your residual, and then you're going to put show squares. You'll see that one. And when you hit show squares, this is what it comes up to. It comes up to something like this. And these squares, remember in our last lesson, all of these distances, remember these are my residuals. And the residuals were just the distance between the actual point and the prediction line. So this one has no line at all because it is exactly there. And so this is what your calculator does, is it finds the absolutely smallest area of all of the squares from this line, and then puts a line, calculates where the line is going to be, and as a result of what the complete smallest area of all the squares are going to be. What I'd like you to go ahead and do is just kind of grab the points, and you can pull them around on your calculator. In class we're going to be doing that, but it's not allowing me to do this on this one. So we might be able to do it here, actually. All right. So for this one, we're going to calculate the least squared regression line, which we did, and I just had it just calculate it for me. Well, the y-intercept is negative 15.1, and it means for a student with a GPA of 0, we predict an ACT score of negative 15.1. Of course, we're going to be careful of extrapolation because, look, my GPA is 0, or is 3, and my y-intercept is 0, and that's outside of my data. And because it's outside of my data, if it's anything lower than 3 or higher than 4, my prediction might not be correct. So you have to make sure that you state that. The slope's 11.5. That means for every point it gets higher in GPA. For every 1 GPA point that's higher, we predict the ACT score is going to increase by 11.5 points. Now let's add one more student with a GPA of 3.0 and an SAT of 28. Okay, and so when we do that, let's see what happens. So I'm going to do 3 and 28. Okay. Oh, this is not the right one. Hold on. There we go. 3 and 28. There we go. So you can see this one in the top left corner is now an outlier. And you can see that the line has shifted quite a bit. Okay? So, adding the point increased the y-intercept. It also decreased the slope. All right, so in increasing the y-intercept, you can see, but it also made it tilt, so it decreased the slope. Here's your learning target. Okay, least squares means it minimizes the sum of the squares of the residual. And you can use the calculator or an app to always find the equation. We're going to be using a little app here to be able to kind of see what happens to the lines, and it pulls it up and down to be able to kind of play with the different lines, and you can have it go up and down and see what happens to the lines. So let me pull that up. Okay, so I'm just going to put some data here on here. And you can see, there's the regression line. And you're going to see what happens here. Now, this here is the mean. This is not, let me just show you what this is. This is your x-axis, or your y-axis, and this is your x-axis. This here is the mean of your x's and the mean of your y's. So it is not at all your x, it is not your x and y axis. This is not the origin. This is the mean. So meaning, what I've done is I've taken all these values on the x-axis and found the average, and that's where I get this point right here. And I've done the same thing with the y, and I get this point. And this point is actually average of x's, that's x bar, and average of y's, y bar. I'm going to remove this, but I want you to see that that line that's not the origin. So I just want you to see something. So watch here. As I take a line, as I take it, an outlier goes up, you can see the line moves up and down. Okay, the line's moving up and down, but the slope's not changing. Now, if I have it go right and left, you can definitely see the slope and the y-intercept are changing. Okay, so that's kind of what we're looking at here. So you can see how the line pulls up when I went up and down, and it tilts the line when I go left and right. The regression to the mean, extreme values for x tend to be paired with less extreme values for y. Okay, for our lesson application today, calculate this least squared regression line. So here's your data. Now this is one thing I want you to notice though. This data all goes together in the same, like on your spreadsheet. And then this data all goes together So don't make each one of them separate. It just ran out of room. So it's the same thing. So protein and then calories. And then you're going to make this line, or you're going to make this data, and then go ahead and do your line. And it gives you your least squared regression line, and your least squared regression line is going to be number of calories hat equals 228.413 minus 8.254 times the amount of protein. The outlier in the scatter plot has to do with Trader Joe's Greek yogurt, and the effect that it has on it is that it's not within the trend of the data, and so what happens is it's just going to pull it up. It pulls the line up. It does it similarly to the one that we were just working with. And here, when you had this one here, and I was pulling it up. So you can see that it's just going to pull it up. If it disappeared, you can see it's this here. If it disappeared, let's take that out, and you're going to watch what happens. So it just moved down. I put it in, and it moves up. I take it out, it moves back down. All right, thank you so much.